So, hi everyone. So today we are going to cover count set bits question. It's bit operation question. So let's directly jump to the problem. So we have been given a number and we have to count the set bits in that number. So what I mean is, for example, 5 can be represented by in binary by 101, right? So I can write 0, 0, 0 and 32 29 to be precise, 29 zeros, and then a 1, and then 0, and then 1 again. So this is the binary representation of 5. How I came up to this, it's very easy. If you remember in the 10th standard, we used to do something like this, right? We used to put 5 over here and 2 over here because it's binary, so we need to divide 5 repetitively. So 2 multiplied by 2 gives us 4 and the remainder will be 1, and 2 multiplied by 1 will give me 2, so the remainder will be 0. So a remainder we need to write it directly here, like for 5 the remainder was 1, for 2 the remainder is 0. So in the reverse order we used to write those bits. So the first this one is going to come, so 1 0 and 1. So this is the binary representation of 5. In here we can easily see that we have two set bits, this one and this one. Set bits means the bits which are turned on or have value 1. So let's think of a naive approach. So quickly think of a naive approach. Okay. So what I thought of was repetitively getting the last bit. For example, here one and checking if it is not equal to zero. If it is not equal to zero, I'll maintain a variable which will uh, update its value, or I would say it would increment by one. And after that, removing this bit and moving ahead. Okay. This is my simple approach. Let me write down the solution and then we'll try them. So I'll create a function. It's basically a function which will return an integer value, and I'll name it as count, and sorry, count, and it takes input as int n. Okay, I'll maintain a variable. It's an int type variable, and its value is going to be 0 initially. Initially the value is going to be 0. After that, I'm gonna iterate over all the bits. How would I do it? That's very easy. We actually have done this here. How? Let's see. I'll start a while loop will um, which will eventually iterate all the bits. So while n is greater than 0, I want this loop to be continuous. So uh, first of all, we need the last bit. How will I get the last bit? I can get the last bit by taking the remainder of the number by 2. So n modulus 2 will give me the last bit, right? So I will check if this last bit is not equal to 0, then I'll increment the value of res. Okay. So how will I check if, so basically what's happening here is that when I I divide 5 and I check for its remainder, it gives me the last bit. It's here, right, in front of you. When I divided 5 with 2 and checked for the remainder, it was 1. And 1 here is the last bit. 1 is this bit because we wrote it in reverse order, right? So this is the first bit, this is the second bit, and this is the third bit. Anyway, so this always gives us the last bit, and if we check if it is not equal to 0, then it must be equal to 1, and we increment its value. And at last, we need to remove this bit, right? That was our idea. We check if it is 1, and after checking if it is 1, I remove it simply. So to remove it, I will simply divide it by 2. N is equals to n by 2, right? Simple idea. So this is the whole program, and at last, I'm gonna return the value of this response res variable. Okay, so let's try run it. Initially, let's take this example only 5 1. Initially, our bits was 1 0 1.